Hey everyone. I'm gonna say it. What a gong show. What is with having a official snow day on day 2 of the week and not an official snow day, forcing everyone back to school on the Monday of the week? I got so much more to say and I can vent on and on and on, but your time is valuable and you don't need to listen to me talk so much. So let's get to it. This video is purely voluntary, but after my little speech about, finding the good fight and pushing through, finishing what you started and all that jazz, it would be very, I'm going to say, hypocritical of me to not provide you with what you need for your continued success just because the next day is an official snow day. And so here I am, trying to create a video for you. This video is going to be purely voluntary as TDSP has said. But I think with all the time that you might have tomorrow, you'll be at least able to spare. I'm going to give it 30, 45 minutes of your time. I'm just predicting. I have two Minds On questions for you, both linked to chapter 8.1. That would be sum and difference of functions. We're going to go into the handout for 8.2 that's already online. And then I'm gonna get you all to stay tuned for some news on our Chapter 8 quest that may or may not change depending on, I guess, the circumstances for the following week. Like we may have to even just cancel it. I mean, just don't get your hopes up or don't bet on it. But I mean, with the circumstances that we are in, uh, I think there may be a reason for us to either reschedule or change or modify or something. Okay. In terms of the culminating, we're still at it, but here we go. So Mind's On. As I go on, you will see me do a bunch of questions without waiting for you. Every single question that we do, I'm going to announce what question we are going to do, at which point feel free. In fact, I encourage you to pause the video and try it. And then once you have given it a shot, sort of look at my answers and see the little extra little pointers that I might mention. Okay, so Minds On questions 1 and 2 are both based on sum and difference of functions. If f of x was equal to x squared, that is a quadratic, a parabola, and g of x is x plus 1, that is linear, what is or are the x-intercepts of f minus g of x? And once I talk about that, is there a relationship between this and that? And is there a shortcut for it? Blah, blah, blah. We'll talk about it. So firstly, as opposed to looking at each function separately, I think it makes sense to actually figure out what the equation is. So just like our homework, I'm just going to call this h of x, and that would be f of x minus g of x, which turns into x squared minus x plus 12, which is going to be x squared minus x minus 12. Okay, so let's get to it. If we were to look for the x-intercepts, clearly you notice that this is in the form of a parabola, that is a quadratic function. And so I am going to factor it, and luckily this is factorable, to see what the x values ought to be. If the y value was a 0, my x values would be a 4 or a -3. Okay, that's pretty much it. Notice how it's a little bit different. When you're talking about x-intercepts, it's very difficult to get to these numbers just from the independent components, right? X squared is like that. X plus 12 is like that. There's nothing here. So if this was my x-intercept, that would be -12, and my x-intercept here is just a 0. There's nothing here that would reveal the final answers are in fact 4 and -3. So it is what it is. Okay, but here's one way to answer it. So there will be questions where you may be required to find the joint or the, I guess, the added or subtracted formula or the function, sorry, and work from it from there, hoping that the final product is in fact something that you are very comfortable or very familiar with to working with. Okay, let's move on. Number 2, what is a domain of the sum of f of g if these two functions are defined as is? Let's give it a shot. Number 2 is a little bit more, I guess, applicable with the superposition as well as by definition, how the domains are defined when you are adding functions. Let's talk about the domain of each individual component. For x could be any real numbers. However, we know that the discriminant, or rather the number underneath the square root, cannot be a negative value. So 2x minus 4 must be greater than or equal to a 0. Well, pretending this is an equal sign, let's solve this inequality. So 2x must be greater than a 4, so I add 4, and then divide both sides by 2. X must be greater than or equal to 2. So the domain for f of x is x belongs to, or is an element of a real number, such that x must be greater than or equal to 2. For g, same idea. X belongs to any real number, and anything goes, except for the fact that an x value is in the denominator. The only restriction I have is that x cannot be a 3. Ooh, take a look. X must be greater than or 2, but x cannot be a 3. So both restrictions have to be, I'm going to say respected, or have to be considered when we are dealing with the joint or the compounded function, or the, I guess, the added function. So, sorry, there shouldn't be an equal sign. For h of x, the domain is such that x belongs to any real numbers, but x has to be greater than 2, and x cannot be equal to a positive 3. Okay. And so in this particular case, we're just taking whatever we have and just throwing it in there like it was a bag of popcorn. Please recognize that there are certain situations where the domains in fact overlap, so you don't have to specify both. For example, let's say for whatever circumstance, this was actually x has to be less than or equal to a 2. Let's pretend, hypothetically. And for the other one, it was x cannot be a 3. Well, if x has to be less than a 2, then for sure it won't ever be a 3 anyways. And so you don't even have to mention that because this already includes the fact that x cannot be a 3. So in that particular case, all you would have to write is just x is that, because this part would be redundant. It's just a hypothetical case, but just showing you how domains sort of combine together when you're dealing with adding or subtracting functions. Okay. All right. Those are my minds on. Moving on to 8.2. So on our Brightspace, you should see this handout available to you. We're going to go through these examples and try to hammer out how you might be able to sketch this combined function, talk about this domain and its range. Same thing with the division. How do we sketch it? State and domain and range. And there's some homework pages for you from the textbook. Here we go. The same principles from 8.1 apply to products and quotients of functions. For quotients, the domain has an additional restriction, obviously, because you have a denominator now. And the denominator can't be a 0. You will recognize past knowledge of graph sketching from chapters 1 to 3. Okay. Please also note that in terms of domain, it's not as simple as putting domains of the components together. When you are dealing with products or quotients, it's sort of like an entirely different monster. You have to look at the resulting function and hammer out the domain and range from that based on your, I guess, creative thinking process. So here we go. New notation. Instead of saying f of x multiplied by g of x, you can always write it as f of x dot g of x. And because mathematicians are lazy, we literally just say f and g are multiple f dot g. Of what? Well, with respect to x. So there it is. So h of x is going to be equal to f of x multiplied by that. So at this time, if you want to pause it and just give it a shot, you could. If not, Follow with me. I'm going to expand this just for the sake of it. That would be x cubed plus 8x squared plus 15x plus 3x squared plus 24x plus 45. Grouping like terms, we have x cubed plus 11x squared plus 39x plus 45. Oh, and look at that. It's a cubic. It's going to be something like that. A quick reminder, because it's an odd function, I know it's going to be starting at quadrant 3. It's going to finish at quadrant 1. The value is the leading coefficient is positive, which means there is no reflection. It's going to stay that way. I don't know if it has point symmetry. I could find out, but that's besides the point because it didn't ask for that. I'm not going to. Another reminder, if I didn't have these components and I asked for the x-intercepts, you would have to find these x-intercepts by factoring. So using factor and remainder theorem. Okay, let's move on. How would I sketch this combined function? Well, if you remember from chapter 1 and chapter 2, the easiest way to sketch a polynomial function is to start with what I said before. What degree is it? And also, what are the x-intercepts? Of course, you can always do our other method of calculating, domain, the intercepts, asymptotes, and do the chart, and to figure out what the end behaviors are, et cetera, and then graph it. But polynomial functions are a little bit more straightforward in that all we need to know is, where does it start? Where does it end? Where are my x-intercepts? Where's my y-intercept? And just sort of eyeball it. So here we go. Using my previous components, I'm actually going to find the factored form of this. And if you notice, x squared plus 8x plus 15 is factorable. That is going to be x plus 3 with 2 brackets, x with x. 3 times 5 is 15, 3 plus 5 is 8. There it is. So my x-intercepts are going to be -3, -3, and -5. -3 is order 2. Okay. Also, it's really helpful if I find the y-intercept. So what is this value when y equals 0? That would be 3 and 0, 0, 15. The value is 45. Okay, so my y-intercept is 45. Let's sketch it. Straight line. Straight line. We've got -3 here, a -5 here. This is not to scale. We've got 45 as my y-intercept. I know it starts at quadrant 3, and I know it finishes quadrant 1. And number 3 is order 2, so it sort of touches. So we've got something, something like that. Okay, please note, I don't know what that local max is because I have no means of calculating it. You need calculus to really make that easy. And that curve is supposed to go through the y-intercept, 45. So let's talk domain. With this sketch, it's a lot easier to talk about domain and range. Domain would be going once, going twice. X could be any real number. There are no restrictions. Range, same thing. Something that you might know about odd functions. It starts from quadrant 3 and it ends in quadrant 1. It spans the entire thing. And you know that domain and range, there is, you don't have to specify what the local max and min is because the y values will overtake and the x values will overtake. That's it. That's how you multiply. Let's move on to quotients. Again, if you're copying this or if you want to try it again by yourself, pause the video now. Next example is when you are dividing. And again, we are essentially creating a denominator when we do this. So you have to watch out. Here we go. H of x is f divided by g. And by habit, or yeah, by habit, I'm going to factor it just in case it can be simplified. And lo and behold, yes, it can. So in fact, the h of x is actually a linear equation. It's going to be super easy to draw, except for, oh, sorry, it's going to be a reciprocal function, which is really easy to draw, except we're going to have to watch out for restrictions. Already, just from this, what are my restrictions? X cannot be a -3. In fact, it's a whole because it was canceled. Remember that? X also cannot be a -5. Why? Because it's a denominator. This is going to be a vertical asymptote. Now, in this question, some of you might remember how to do the DIAC, that is, calculate the domain with the restrictions, give me the x-intercepts, the y-intercepts, give me all possible asymptotes, and then do the chart method to figure out what goes up and what goes down. Another way you can look at this is the fact that it is a reciprocal function, that looks like this, with asymptotes at 0 and 0. Okay. Or, and that has been transformed into x plus 5. Right. Okay. And so which way you want to do it? For me, I'm going to actually just do it as a transformation 5 units to the left. It's just a lot easier for me. If you want to do DIAC, by all means, go for it. Here we go. Okay. Originally, my intercepts are, sorry, my asymptotes are here, here, and my reciprocal function is here, is here. Remember, I'm just using this from my original knowledge that f of x reciprocal function is just 1/x. It has two asymptotes. Now, my x plus 5, that means I'm shifting everything to the right. My horizontal asymptote does not change. Whether I move left or right, that's not going to change at all. But if I move to the left, my vertical asymptote will also shift left, 5 units left to be exact. And so using that as my, I guess, that's my point, I'm going to have something like this and something like that. Okay. So that is, the red is my new h of x. But of course, I can't forget, the vertical asymptote is already here, so that's fine, but a -3 also cannot exist. So I'm going to draw a hole for myself right there. Hole. That's it. Let's take the domain. For the domain, x can be any real number, but such that there's an element of real number such that x cannot be a -3 or a -5. Done. For the range, just because you know what it looks like, you should be able to tell me that y cannot equal a 0, which is the horizontal asymptote. And there it is. So is there a way for us to use the components to tell me what all these are? Well, yes, there is. It's the fact that you have a parabola, you have a quadratic as a denominator. And typically a quadratic could, in fact, have 2 zeros. In other words, there are 2 locations where the denominator could be a 0. And lo and behold, that's exactly what those 2 are. Right? That's pretty much it, right? So this is what I wanted to say. When you are multiplying or dividing functions, it is in your best interest to actually find the combined function instead of trying to work with its pieces. I don't think it's as efficient. All right. Now, with that said, you can totally pause the video and try it out yourself or try some of the homework questions. Once you've given yourself some exposure, I'm going to provide for you 2 different questions. One is a food for thought, and the other one is, well, you know what? They're both food for thoughts. I have a question where I ask about even and odds again. So when you are ready, here we go. The first one, let's assume that h of x is equal to f dot g. If f of x has x-intercepts at 1 and 2, and then g of x has x-intercepts at 3 and 4, what are the x-intercepts at for h? Pause the video and think about it. You shouldn't think about this too in a complicated way. I didn't give you any equation, so you're actually not supposed to solve it per se. But consider this: if h was at 1 by superposition principle, then that would be f of 1 times g of 1. Well, what is the value of f of x when x equals 1? It's a 0. So when h equals 1, that's 0 multiplied by whatever number this is. But I don't care because it's multiplying by a 0. It's a 0. If x equals 2, again, by superposition principle, it's f of 2 times g of 2, which means 0 times 0, 2. That's a 0. And in the same way, it will be the exact same thing at 3, as well as 4. It will be f of 4 times a 0. In other words, h of x has x-intercepts at all 4 points. Okay. Just a food for thought. Here's another something that you can think about. Okay, it's going to be one of those even and odd questions. Okay, let's try. Let's try. Yeah, you know what? Let's try even times even. If f of x was even and g of x was even, what would h of x be? If I defined h of x equals f of x times g of x. Okay. Would it be even? Would it be odd? Would it be neither? Think about it, then pause the video. Just like our previous lesson, I'm going to try to hammer it out. All right, recall, if something is even, that means f of x is the same y value as if I had a horizontal reflection. Okay, so let's do this. If I have h of negative x, by superposition principle, that is f of negative x multiplied by g of negative x. But remember, we've already defined f of x as even and g of x as even, which means f of negative x is the same as f of x. And g of negative x is the same as g of x. And all of a sudden, what did we just prove? This definition for h of negative x is the same definition of just h of x, which means these two must be equal. H of x is equal to h of negative x. So if an even function and an even function are multiplied, the combined function will also be even. Yay. But what if f of x was odd? And what if g of x was odd? What would h of x be? And again, I'm defining h of x as this multiplied by that. And remember that if it's odd, a vertical reflection will give you the same curve as if I did a horizontal reflection. Okay, that's what odd means. So here we go. Let's take this. Let's multiply by a negative, right? Let's do a vertical reflection first, and that is the same as multiplying this entire thing, right? Which doesn't change anything. It's just negative times f of x times g of x. Good. Now let's plug in h of negative x, which is the same as f of negative x times g of negative x. And remember, f of x is odd, g of x is odd. So this can be rewritten as f of a negative f of x multiplied by, and g of negative x could be written as negative g of x. So a negative is being multiplied by a negative. I get a positive f of x times g of x. So wait a minute. Are they the same? No, they're not the same. Therefore, if I have an f of x that's odd, and if I have a g of x that's odd, and I multiply them, h of x is not odd. In fact, guess what I get? F of h of negative x being f of x times g of x is the same as hx. In other words, if I have an odd function and I multiply it with an odd function, f of x is, h of x is actually even. Surprise. Okay. Just some interesting facts that we can try. Again, this is proving algebraically without actually using equations. This is proving every single scenario works as opposed to giving case examples. It's much more efficient and a lot more powerful. Please give yourself an opportunity to work through as many textbook questions as possible. And again, as a reminder, stay tuned for your Chapter 8 quest. I guess potential changes to schedule or even the existence of Chapter 8 as a quest. Okay. Yeah, hope this video wasn't too long and hang in there. We will see you hopefully on Wednesday. Bye.